So, next up, Daniel, stage is yours.
Thank you very much. I think I'll just use the, very good. I'll use the keyboard because I have many slides. So I think your brain is completely full. I think there is nothing else I can put in there, but that will not stop me from trying. Basically, the title of the talk just tells you everything. So, metadata-aware vector embeddings, where the model is basically a mixture of experts. That's what we do. If you have been thinking about ways to inject other signals besides, text embeddings into your vectors, then this is the way to do it. Superlinked was mentioned on one of the slides we saw previously, under the glimmers of hope. So that's good. So yeah, you have those two separate systems, and obviously, in big tech, the way we build vector search systems is we have custom encoders that feature engineer all our observations about the given entity, and then we make an encoder that encodes all of those signals, right? Like if you went to the TikTok recommenders team and told them that, hey, you can hybrid search your, structured, you can do boosts and all of that stuff, that obviously wouldn't fly, right? And our goal is to help you integrate those two worlds, the structured data and the unstructured. I don't have to tell you what embeddings are, but basically, what if your data is not just text, because it isn't, right? So you have some object with some rating and description. Wouldn't it be cool to have some way to make vectors that somehow encode the numbers, let's say, and the text in a way that is kind of reasonable? So not by stringifying the number and encoding it with a language encoder that treats it as text tokens. If you try to do that, this is a very simple experiment you can all replicate. Just take 100 integers, 1 to 100, stringify them, make embeddings, and plot them, and just understand how the latent representation in a text encoder looks like for numbers. It's basically noise, and then obviously it only goes bad from there because you have objects with tens of properties, and those properties are location and numbers and lists of IDs and all of that, right? So how do we go from something like this to embedding? And why do we want to do it? Because when you have a query like this, family-friendly hotels near Manhattan Midtown, wouldn't it be awesome if you could take that query and make an embedding out of it that kind of asks for family-friendly things and hotels and things near Manhattan Midtown, all encoded in the embedding itself, right? Without the extra treatment. And then what about we can inject all kinds of biases in there? There can be context of the user, right? Where is the user located and which hotels they booked before, right? Imagine you have some way to take all of this and make an embedding out of it that encodes all of that stuff. And the question is why? Okay, so when you work on a search system, basically we're running a multi-year optimization over the space of potential query JSONs in your open search system, and you have all these tricks and things you are using to search this space of queries that you are hoping to encode with that JSON query, right? And it's actually kind of hard to optimize over JSON space of JSON objects, right? This is not smooth. This is not what ML people like to do. And so wouldn't it be better if somehow you could make a user vector that encodes everything you know about the user, make a query vector that encodes all those biases in the query. Okay, this is my other query, but similar idea. And then you can kind of just pull that query closer to the user. Okay, that's search personalization. And then you can look up, your hotels or whatever it is in that same space. This is then what you are optimizing over, right? Much more straightforward. We have an open source product that helps you do this stuff. It feels like building some stuff in Python. And basically what this does, the way this fits in your stack is you have your data and your use cases, and then we have encoders for different kinds of, I don't want to say modalities, because then people think text and images. We have all kinds of other stuff. And then we sit on top of a vector database. So we work with Redis, Mongo, and Quadrant. We are adding more. I just got a text that we spun up with the customer another like a 2 terabyte Redis instance today, so I'm looking forward to that bill. And I mean, I added this slide just for you. I don't show this anywhere else. You are all very nerdy, so I added this one. Just basically and you know, like we have a sponsored dinner tomorrow, and I will not be able to explain this right now. So basically, my call to action is come to our dinner and let's chat. But basically, we have like a DAG object we create that contains both this idea of encoding all kinds of signals into the vector and then aggregating that vector with other vectors and eventually coming up with a search object that then we use to search in the underlying vector index in the database. Lots of use cases, obviously. We have some resources. We have a table that compares 47 different vector databases on maybe like 40 different features. This is open source, and more. And basically, choose your own adventure. I have 3 QR codes. I have the most QR codes per slide. Okay, and the 3 options are dinner for tomorrow, these slides, so there is like self-referential element, and then our GitHub, where basically kind of a lot of what I described is available, Apache 2.0, go check it out. And then we have a private preview cloud product if you want to scale it to like those 2 terabyte Redis instances. Thank you.
Thank you.